So to finish off section 3, we're going to talk about the triple scalar product. Now, triple scalar product is actually that process when you cross multiply two vectors together and dot them with a third vector. Okay? So, what ends up happening, you actually end up forming a matrix made out of all the coefficients from that vector. All the x, y, z coordinate parts from that vector. What does it mean when you have absolute value bars around that matrix?
You finally answer it's going to be positive.
Nope.
No, never mind.
What other process are you supposed to do when it has absolute value bars around this matrix like that? Nobody? Where's the D? Determinant. Absolute value bars like that just mean find the determinant. Okay? Now, the reason for this is because when you start talking three-dimensional, some things are easy. Like, how do you find the volume of a box? Yeah, length times width times height, right? Pretty much any object, it's the area of the base times the height, like cylinder, things like that, right? Any general object. You can actually get some kind of bizarre shapes that this will help with, though. Using that triple scalar product, I can actually find the volume of what's called a parallel pipette. Well, box, the actual name for the box that you're thinking of, anybody know what the actual name is? Heard the term rectangular prism before?
Oh, yeah.
Regular box where all the faces are rectangles is what's called a rectangular prism. Well, if you have one that is a polyhedron but all the faces are parallelograms instead, that's called a parallel pipette. Okay? And you can actually find the volume of this, because what happens when you do the cross product of V and W down here, you get the area of this base. The height then ends up being a projection of this U vector onto that cross product vector, which is perpendicular to that base. But the nice thing about all this is because of that, you can actually just take the absolute value of that triple scalar product. In other words, that's just the absolute value of that determinant. So if you ever need to find the volume of a parallel pipette, and you will, you want to find the determinant of the matrix formed by these, and then do the absolute value. So if I have this one, well, what's my matrix going to look like? 1, 2, negative 1. Middle row? Bottom row? 2, 0, 1. And I want to take the determinant of that. Now, does anybody remember how to do the determinant? Here's the long way is what we were doing last week, right? When you have I, J, K there, you're kind of forced to. Where you cover up the row, cover up the column, do all that. But because I have all numbers here, I can actually do it a different way. What? Well, that's going to take you longer. You could.
You do the basket weave.
You do the basket weave, okay? If you want to try the calculator, go for it. But basket weave, how do I do that?
You add first two rows.
Yeah.
So add 1, 2, negative 1, and negative 1, 2, 2?
No. First two columns.
First two columns onto the end. So if I do that, I'm going to duplicate 1, negative 1, 2, 2, 2, 0. Then what?
Then 3. Like. Yeah.
Diagonals, the word Josh couldn't remember. Do multiply your diagonals. So 1, 2, 1 gives me
2.
next.
8.
Lastly,
0.
what do I do with those? You add them up. Gives you 10. Now what? The upward diagonals. So what do I get first? Giving me negative 6. Then what? Subtract what from what? Yeah, it's always that bottom number minus the top number, because it's coming from the same idea as that 2 by 2 one. Downward diagonal minus upward diagonal. Giving you 16. Now, technically, this is also the absolute value of this, which is still 16. So the volume of that parallelepiped with the adjacent edges being those vectors would be 16 cubic units. Easy enough? That's actually it for section 3. Tomorrow we'll look at section 6. Spend a couple days on section 6 of chapter 10. Then spend a couple days on chapter 11, section 4. Friday no school, Monday review, Tuesday test. And I've added